Hi YouTube, welcome back to part 3 of the snowblower build. So I've been getting a lot of great comments from you guys, great tips and advice, also experiences from building snowblowers, and I'm very thankful for all of these comments because they do help me a lot designing and thinking from other perspectives. And yesterday when I got back inside, this is after I was filming, I noticed that the impeller motor was pretty darn hot. Some of you are right about the motor being too quick and it bogging down and becoming hot, and I'm concerned that this might melt some parts and cause mayhem in there. So I think I'm going to redesign the impeller motor, the entire area with the impeller motor, and I need to find a motor that is stronger and a little slower. And somebody suggested to go brushless, and that's a good idea actually, but I'll have a look into it and we will see what I can come up with. In the meantime, I'm going to put the loader outside now and give it a really hard test. We've got some hard packed snow laying outside, so I'm going to run it straight down and see what happens to the impeller motor. I'm pretty sure it will melt the plastic, but we'll see. Anyway, I'll see you guys outside. So I'm going to let it sit here and let the snow melt off before I look into it. Now I'm pretty sure that the impeller motor plate has warped or something, because the impeller is now hitting the walls. So it's back to the drawing board for the impeller at least. The auger seems to be working pretty well though. So yeah, I'm going to look for some parts and see what's available and have to, yeah, begin from scratch on the impeller. So we are back on the workbench and we have more new parts. And actually what happened was that the impeller motor rattled the screws loose, so the impeller fell down and touched the wall here, but that's okay. I'm throwing the impeller away anyway, because on this design I made a new one. And I've received a lot of tips over the last few days, and I'm very thankful for the tips I get. The new impeller, I moved, you can see, I moved these down on the circle. It's hard to explain, but you can see the difference. This one, in theory, should throw the snow a lot better than the old one. So the old one goes in the bin. And also this time I'm going to reduce the motor speed by half. So when this motor spins 2 rounds, the impeller will spin 1 round. So I'm reducing it from 2 to 1. And I also ordered from AliExpress some gears with a 2 GT belt. I ordered 2 to 1 and 3 to 1. I ordered both of them just to make sure that get this thing going the way I want it. Now in the meantime, I did have a 2 GT belt, but it's a little long, and I also had one gear. This is, I believe, a 36 tooth gear. So in order to reduce that down to half, I designed and 3D printed this pinion gear. This is a 17 tooth, so it's not really 2 to 1, but it's close enough. So let's assemble the new parts and try out the belt drive and see how that goes. So this is the new impeller housing, or the impeller mount if you'd like. Now this should be sitting on the back here, and then the motor will sit up here. Let's put that out of the way. Like this, and then this is how I'm putting the impeller on there. And you can see that I put on another adapter in here, because in the future, if this works, I won't be using a 5mm rod. I'm going for 8mm because these bearings are pretty small and this will spin at high rate of speed. So I want them to be 8mm. So that's why I got a 8mm coupler on here. The reason I went for 5 on this one is because the gear that I had is 5mm in the bore. So in the future, this will most likely be 8mm with bigger bearings. I will be using these bearings instead. Yeah. So let's get this impeller mounted up. It's going down like this, all the way in. And now I can mount this gear on the back side. First I'm going to grind a small groove here, like I've done on the impeller already. Here you can see. So I'm going to grind a groove on this one now. So on the impeller, I won't be using the set screws. I'm going to be using 4mm screws. I put 2 screws in it because I don't want this thing to be unbalanced. Also, I don't over tighten the screws, because if I do, I will probably hurt the plastic shim or the adapter that I made. On this piece I will be using the set screws, because this doesn't have plastic in here. And now I'm going to try to line up the belt drive. Okay, I can't get this one further in than that, so I'm going to have to move this one out, unfortunately. So I put 2 washers on it now, and it seems to be perfect. So I'm going to create another flat spot now, and I'm going to use my Dremel for this, since I don't want to take off this whole thing again. Yeah, that's better. So let's get the idle wheels mounted up, because this belt is way too long for this setup, as you can see. So I have to put some idlers on it. So it should be something like this, probably. And don't worry guys, this is just a mock-up to see if the reduction works. Once I receive the parts from AliExpress, I will fine-tune where the motor will sit, and yeah, the belt will be much easier to mount up for those who purchase these files in the future. So don't worry about this yet. This won't stay like this. So for this cover, this small cover, I need to make a change, because I can't access the screw on this side now, but I will change that in the future. So I'm going to add 1 screw here until then. Okay, so now we can begin looking at the belt drive. We need to put a couple of idler wheels. One will have a spring on it, so it will put a small tension on the belt. I haven't designed the spring yet, but I will have to mount up everything first and then design the spring for it. I don't recommend using self-tapping screws for this, but I'm just using this for testing purposes. So now I need to create a small spring-loaded mount for this idler. So here's the so-called spring, and the idea is that this will keep tension on the belt. So the belt is now mounted on. I haven't tested it yet, but I got the battery here. So let's plug it in and see what happens. Gotta watch my fingers though. And I have to reverse the motor now since it's sitting this way and not that way. So I'll go ahead and take off the motor and reverse the wires for it. And then I can create a cover that will sit over the belt drive. And on that cover I can mount this thing. So I reversed the wires on the motor, and unfortunately I forgot to put on this cover. Now I'll keep testing without this cover for now. I did, however, create the belt cover that hopefully my calculations are correct on these mounting holes. If I did it right, none of these holes should touch any of these parts inside here. Let's see here. Yeah, perfect. In order to get the holes correct, I just have to put it this way. Now in the future versions, of course, the holes will already be there, but since this is just a mock-up, I have no holes to mount it onto. Alright, so now we can mount this part onto these smaller holes right here. Alright, so I created some new sliders for it. Alright, so this print could have been better, but I don't really mind. I don't care about this. The differences between these you can see right here. This is the new one, this is the old one. The old one kind of dug down into the ground because it's very pointy here. You can even see it's been worn down already on the tip. So that was one of the problems that annoyed me when I tested it, that it dug down and got stuck. So this time I created just a blunt edge so that it kind of floats like a ski on top of the snow, and hopefully it doesn't get stuck as much now like it did before. Alright, the belt drive version is now ready for some testing. And I think I'll just put it on the loader and go outside and give it a little test run. And by the way, for those of you who didn't like the whiny sound on the old one, this is probably a lot better. You can hear the sound now. It doesn't scream as much anymore, so I guess that's a good thing. Anyway, let's go outside. The snow is pretty hard. I'm using my shovel. You can see that it flakes up like this. Unfortunately, my loader isn't heavy enough to go through this. The snowblower, however, seems to eat through this pretty easily. the motor is not even hot. Alright guys, I've been outside for, let's see, 35 minutes and I tested the snowblower non-stop. I actually am going out of battery on my phone right now, so that's why I went inside, but I was thinking we could check how much battery we have left on this. Okay, I need to plug in my charger on the phone. So let's see here. Okay, so 55%. This was at 95% when I started. So we drained 40% of a 5200 milliamps battery in 35 minutes. Which is, it's not bad really, it's okay. Well, this test run with the belt drive system really worked out well. And the good news is that now that I know we have a system that's working, I can design something for final release for the files, for those who wants to buy and build this. I do, however, have to wait for the order from AliExpress to come with the gears, because in the video you can hear that it's jumping over the gears a lot, and I suspect that's because I 3D printed the pinion gear. The plastic is very slippery, so unfortunately I won't be able to release any files until I get that order. But that's okay, at least we know that this thing works. Now the snow that I'm using this in, on the video I'm not sure it shows, but the snow is very icy and it's hard, very hard today. We had rain earlier today, so that's why we have this hard surface on top. But it didn't really matter much because the teeth on the auger seemed to chew away on it. I want to say thank you for all of you who posted tips and had all these cool comments about snowblowers. All of this info really helped me design this thing. Well, this wraps up this video. If you like this video, please give me a thumbs up and I'll see you soon. Bye bye.